What's the only thing that you can have in an empty pocket besides air, of course? The answer is a hole. You can have a hole in an empty pocket, and it's still empty. Okay, so finally, if you notice, I want you to take a look at, I'm going to dive right in here. We're still using the ratio test, and we're going to use the ratio test for all kinds of different series. But for the first time in this entire packet, and from here on out, really you're going to be using the ratio test to determine an interval of convergence or a radius of convergence. And I want you to notice something about this particular series that you see here. It's the first one that actually has an x in it. Okay, and so this ratio test, when you're asked to find the radius of convergence, or you're asked to find an interval of convergence, or the interval of convergence, I should say, you're going to be using the ratio test. That's the most helpful test in finding the radius of convergence. Now, when you see on the AP exam radius of convergence, you're thinking to yourself, cool, I don't have to test the endpoints. No need to test the endpoints, and that'll make more sense as we do more of these examples. But if you're just finding the radius, then whether the endpoints are included in the interval of convergence or not, the radius remains the same. So that's why you don't have to test the endpoints. Okay, so our example number 11, we're going to use the ratio test. And so again, this is where you really want to dial in. Okay, because this is going to be the thing you're going to see on the AP exam almost every year. They have the same exact problem. So limit as n approaches infinity of a sub n plus 1 over a sub n is equal to the limit n approaches infinity, absolute value. And then if you notice here, this series, everywhere you see an n, for a sub n plus 1, you're going to put an n plus 1. So this is going to be n plus 1 multiplied by x to the n plus 1 divided by 10 to the n plus 1. Okay, like I said, I'm not going to put divided by a sub n. I'm going to multiply by the reciprocal, save a little bit of time and save some writing. So multiplying by the reciprocal of a sub n would be 10 to the n down here, means 10 to the n up here, and we have n times x to the nth power. Okay, so here's our limit of our absolute value of this, all this stuff, and let's simplify what's inside. We've got limit as n approaches infinity. Now we do have an n plus 1. We have an x to the nth power times an x to the first. So any exponents that you see that we have where we have a sum of two different things, then we can split that up. Usually it helps us simplify. 10 to the n times 10 to the 1 times n times x to the n. So the first thing I normally do is I will just simplify all the exponents. Okay, and we can see we have an x to the nth up on top and on the bottom, so we're going to cancel those. We have a 10 to the n up on top and on the bottom. This 10 right here, this is just absolute value of 10 in the denominator. Well, this right here is an x up here. This has not impacted by the n approaching infinity, and so we can bring that out as well. So let's see what happens there. We have absolute value of x over the 10, and then so anything that has an n in it, we're going to leave it in there, multiplied by the limit as n approaches infinity of the absolute value. But what's left over here? We have an n plus 1 over an n. Okay, well, that limit as n approaches infinity, you should realize that this limit here is just 1. That's 1, right? Okay, so we have this absolute value of x over 10. So that's what we're sitting here looking at. All right, and so if you remember what the ratio test says, it says if whatever you get is less than 1, then the series converges. If this, at whatever we got, and we got this absolute value of x over 10 less than 1, then we have converges. I'll just say then converges. I understand it's not proper terminology, but or English grammar. So anyway, let's just solve this. That's all we have to do. Figure out what values of x will the series converge. Okay, we're going to multiply both sides by 10. So we have when the absolute value of x is less than 10. And that means that x has to be between negative 10 and positive 10. But this right here, guys, that right there is our answer. That's our radius of convergence. Radius of convergence. And that's our answer. Okay? That's our radius of convergence. And if you think about it, x being between negative 10 and 10, if you look at this, 0, 10, negative 10, this is our interval of convergence from negative 10 to 10. Now again, we're going to be looking at interval of convergence. We're going to have to check the endpoints as well. But radius of convergence is 10 units. Okay, 0 plus 10, 0 minus 10 gets us to the interval of convergence. Okay, so let's see here. That's 6 minutes. I will go ahead and do example 12, and then we'll talk about the alternating series test. So let's do that now. Let's do the example 12. When finding the interval of convergence, first you find the interval, okay, and then check the endpoints. So this is really, really important. And I want to highlight this, and I want to let you know, number one, it's important because on the AP exam, which you'll see some examples next time you come in, on the AP exam they say, what is the interval of convergence? And it's an FRQ. You're going to get 1 point just for checking to see if the endpoints are included in the interval of convergence. So 1 point just to check them. You don't even know how to do it. You just need to be able to, you just need to say checking the endpoints, and then you check the endpoints. If you get them both wrong, then you don't get that second point. But you do get a point just by remembering to check the endpoints. So it's as easy as that to get that little extra point there. And then you have to know a little bit more to determine if the interval of convergence includes the endpoints or not. So let's go ahead and take a look at this particular example. Find the interval of convergence of the series. Okay. Well, this series is if x, let's say, take a look. If n equals 0, we have 1. So x plus 5 to the 0. Okay. And then you have x plus 5 to the first power. And then you have x plus 5 to the second power, and so forth. Well, this should look really familiar. In fact, we're not going to need to use the ratio test here. This is a geometric series. And being that it's a geometric series, what's the r? Well, the r is what you multiply every previous term by to get to the next term. So the r is equal to x plus 5. Okay. So, and what do we say about when geometric series converge? We say, well, when the r is less than 1, series converges. So if x plus 5 in absolute value bars is less than 1, then the series converges. And so what does that mean? Well, it means that x plus 5 is less than 1, but also greater than negative 1. And if you subtract 5 from all three parts, we get x is less than negative 4 and greater than negative 6. Okay, so this is temporarily our interval of convergence. Okay, well, we have to check the endpoints. Okay, because negative 6 might be included, negative 4 might be included, or they might, neither of them might be. So you understand what I mean. So let's check the endpoints. At x equals negative 6, okay, what we get is negative 6. So here we have 0 to infinity. When you plug in negative 6, that's what you're going to do. When x is negative 6, so for the specific value of x, we have negative 1 to the nth power. Negative 1 to the nth power. Well, what does that mean? That means we have 0, right, negative 1 to the 0, sorry. Negative 1 to the 0 is 1, plus negative 1 to the 1, that's negative 1. Okay, and the negative 1 to the second power is 1. Negative 1 to the third power. So what you're seeing here is that you have 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so forth. Okay, and does this series converge or diverge? Well, does it converge to one number? No, you can see that it doesn't converge to one number. You can see that it doesn't converge to one number, so we say it diverges. Okay. The nth term test, the limit is not 0, so the limit doesn't exist, so we can use the nth term test. Okay, so that diverges. So our interval of convergence does not include -6. So what about at x equals -4? At x equals -4. Well, we have our 0 to infinity, and -4 plus 5 is 1, and we have 1 to the n. Okay. Well, 1 to the n is 1 plus 1 plus 1 plus 1, and we've already talked about that one. That one does not converge. In fact, the limit of the nth term goes to 1, and so diverges as well. Okay. So since at the endpoints, each of those endpoints causes the series to diverge, then we say that this guy right here, therefore we would say the interval of convergence is what we said in the beginning. Now, if you said, even though, let's say on the FRQ on the AP exam you said that was your interval of convergence, if you did not include checking the endpoints, you would have missed 2 points for that. So if you don't even include it, you don't even get either one of those points. You have to always check the endpoints. So again, right here in this box it says before we continue with examples 13 and 14, we have to first learn the alternating series test. So that's where we're going to start the next video.